Alright, so in this video we're going to do another example involving limits here. So they're giving us some information here. So they tell us that the limit as x approaches c of some function f is equal to 3. They also tell us that the limit as x approaches c of some function g is equal to negative 4. And finally they give us some information about a function h, and they tell us that the limit as x gets closer to c of this function is equal to 5. And so what they want us to do with this information is use it to evaluate this limit right here, the limit as x approaches c of all this junk right here that you see there. So what we're going to go ahead and do is apply the limit properties that we learned in class to help us evaluate something like this. So the first thing that I'm going to do is use the quotient property, which states that I can simply just write the following limit problem as such. So I'm going to have the limit as x approaches c. So I'm going to take the numerator, I'm going to have the limit as x approaches c of f of x minus, let's see, let me put this in brackets, minus 3 times g of x, and let me close off the bracket, divided by, so this is going to be all over, and let me do this in green here, the limit as x approaches c of h of x. So what I've done is I've just kind of rewritten this limit as the limit of the numerator all over the limit of the denominator. So from here, what I'm going to do to the numerator is separate this, and I'm going to rewrite that as, so let me go ahead and let me work this way. So this becomes the limit as x approaches c of f of x minus the limit as x approaches c of 3 times g of x, and this is all divided by the denominator, which is the limit as x approaches c of h of x. Now one thing that I see here is that I have a constant of 3. So this 3 here, what I can actually do is I can move it to the front of the limit. And so by doing that, what I now have is, let me rewrite it like this, the limit as x approaches c of f of x minus, and again that 3 is going to come out to the front, so that 3 comes out to the front, and what's going to be left is the limit as x approaches c of g of x, right? So that's what's going to be left after I move the 3 out. And then this is all over, this is going to be all over this thing here in green, which is the limit as x approaches c of h of x. Now, if we go back to the information that they gave us, they told us that the limit, so right here in yellow, they told us that the limit as x gets closer and closer to c of the function f is equal to 3. Well, that's this guy right here. So this guy right here is just equal to 3. This here equals 3. And if we continue this, if we look here, the limit in blue, the limit as x approaches c of g of x, that's equal to negative 4. So that means that this piece right here, if we match it up there, this piece right here is equal to negative 4. And then finally, if we finish it off with the last piece of information that they give us, they tell us the limit of h of x as x gets closer to c is equal to 5. Well, that's our denominator here. So as x gets closer to c here of the function h of x, this here is equal to 5. So what we actually now have, is this thing here. So we have, let's see, instead of writing the limit as x approaches c of f of x, I can now just substitute that with 3. And then we have minus, this 3 here in orange just stays there. And then we have a negative 4 in blue, so the limit as x approaches c of g of x, instead of writing all that, I can just substitute negative 4. And then we have a 5 in the denominator. And then again, if we just clean this up in the numerator, so in the numerator we're going to have, let's see, 3 minus 3 times negative 4. Well, negative 3 times a negative 4, that's going to be a positive 12 right here, and 12 plus 3, that is a 15 over 5, and it looks like this whole limit evaluates to a 3.